SS's strict sense stationary stochastic process에 대해서 설명드리겠습니다. For some stochastic processes, the PDF probability density function does not change with time. For example, if we flip a coin 10 times, then we can view that process as a stochastic process with the statistics of process being the same at each time of 10 times instances. In this case, the stochastic process called strict sense stability SSS, or just the stationary for short. In this case, the mean of the stochastic process is constant with respect to time, and the autocorrelation is a function of a time difference, t minus t2 minus t1, not a function of absolute time, ext, x bar constant, ex, then rs t2 minus t1. WSS, wise sense stationary stochastic process. For some stochastic process, these two conditions, 100 and 101, are true, even though the PDF does change with time. Stochastic process for which these two conditions, equation 100 and 101, are true are called WSS, wide sense stationary. A stationary process, wide sense stationary, the wide sense process may or may not be stationary. WSS는 SSS를 포함하죠. From the definition of autocorrelation, if can be shown that for a WSS process, the following properties hold. 마스터 증명을 하면 100일에다가 이렇게 되고 아리스토텔레스 시메트리 시메트리 한다고도 증명을 했네. For Scala stochastic process for T for Cauchy equalities, Bossis inequality or Cauchy-Sieverts inequality 뭐 유명하시겠네. 이거 각자 더해서 제곱한 것은 각각을 제곱해서 더한 것, 각각을 제곱해서 더한 것보다 각각은 적다. ACBD 제곱은 A 제곱 B 제곱. AB는 A 도트의 스칼라는 각 크기 곱해보다 적다. Time average and the continuous time random process. Suppose we have a stochastic process. Further, suppose that the process has realization xt. The time average of xt is denoted time average xt, and the time autocorrelation xt is denoted rst. Time average 이렇게 적이 되네. Time autocorrelation은 이렇게 적이네. The definition for a discrete time random process and are stated for the extension of the continuous time definition. Ergodic process, ergodic process is station process for which used time is designated. What is difference between the time average and the ensemble average? 답은 time average average the equal quantity for a single system over time time interval directly related to the real experiment 시간 평균이 되죠. ensemble average, average quantity of many identical systems at a certain time. 집합 평균. Some random processes have a property of ergodicity. It means that the time averaging is equivalent to the ensemble averaging. This requires that the process to be stationary. This vice versa is in general not true. Stationary process might not be ergodic. Suppose its unit of electrical instrument is manufactured with a small random bias. Is the noise of the instrumentation ergodic? Not ergodic. If we measure the noise of one instrument, then we measure its bias, which is equal to its mean. However, if we measure the noise of another instrument, it might have different mean because it has different bias. In other words, we cannot obtain the mean of a stochastic process by simply investigating. 뒷부분은 원본을 보입시다. Simply investigating one instrument, that is one realization of a stochastic process. Therefore, the state process is not ergodic. Suppose each unit of electrical instrument is manufactured identically. Each general mean stationary Gaussian noise. Is that noise ergodic? Yes, ergodic. Why? In this case, we could measure the mean of the process by measuring the noise of many separate instruments at one instant of time, or by measuring the noise of one instrument over an extended period of time. Either experiment would correctly inform us that the mean of a stochastic process is zero. We could find the statistics of a stochastic process using all the instruments at a single time, or using a single instrument at many different times. Therefore, stochastic process is ergodic. The definition of correlation and covariance can be extended to stochastic processes, D and YT, cross relation of XD, YT. Two random processes, XD and YT, are said to be uncorrelated for all time t. Cross covariance XD and YT is defined. cross covariance. 화이트 노이즈는 컬러드 노이즈는 다음 시간에 하도록 하겠습니다.